We are streaming on the YouTube. We are recording. Hello, everybody. Bam, what is up? Cubic Ray, good to see ya. Cubic Ray, you've been storming through the quest and doing a great job. Hero, what's up? Calcoin, hello. Keto, Surrey Cat, SWT, Willie Blue, the whole squad. Here we are on our last day of the workshop. So, sorry, not the last day of the workshop, but the last workshop of the bootcamp. But wow, yeah, so, yeah, this is workshop 8 out of 8. We extended the bootcamp another week because we figured that it was taking, chapter 5 would take too much time, and it did, because it's a pretty complicated chapter. But so far, we have covered pretty much everything in the bootcamp except for actually implementing the non-fungible token standard on our NFT contract. So we've covered, in the last workshop, we covered contract interfaces, and we covered events, and we also covered, what else did we cover? We covered, what was the other one? Pre and post conditions. And so the reason that we covered those is because we're going to need both of those, we're going to need to understand both of those in order to implement the standard on our NFT contract. So to do that, I'm going to share my screen here. Oh, and another thing we did last time was I taught you how to use the local emulator because the playground was being so buggy. And today, because we're not actually going to be running any transactions or scripts, I'm going to keep using sort of like the VS Code format, the local emulator format, because it's going to be easier for us to see these two contracts. All right. So what we said last time was in order to actually implement a standard or a contract interface, what you're supposed to do is you're supposed to import the contract interface, which we have right here, right? So on the right hand side we have the non-fungible token contract interface / standard. So these are all the requirements that our contract is going to need in order to actually be a real NFT contract. So we're going to spend the entire lesson pretty much taking our baby Jacob contract that we developed in previous workshops, and we're going to fit it to the non-fungible token standard. That's pretty much all we're going to be doing today. Okay, cool. And then at the very end, we're going to go over some like administrative stuff for the bootcamp. I'm going to announce like who's finished so far, and then we'll go over some stuff. So Surrey Cat says, I just started chat with me and I don't understand anything. Well, that's because I think by the end of chapter, yeah, so definitely you'll need to do chapter 4 and 5, Surrey Cat, but you can tag along for now. Okay, awesome. So yeah, here's a baby Jacob contract, and the first thing, as always, is going to be to implement the interface. So let's go ahead and implement the non-fungible token on the contract. Now, woohoo, we're going to get a ton of errors now because when we go to implement the standard, our contract is definitely missing a lot of things. So let's go ahead and see what we're missing. So inside of the standard, what's the first thing we need? We need a total supply. Do we have it? Boom, we already have it. Done. All right, so that's cool. The next thing we need is a public event contract initialized. Do we have that? No, we don't. So we have to go ahead and copy this one, and let's put it into our contract. And in here, let's just put like a little events comment to signify that this group is all the events. So we need a contract initialized. All right, so we have that now. Do we have withdraw? Nope, we need the withdraw event. We need the deposit event, and we should have all the events now. Now we probably want to go ahead and actually omit these somewhere, right? Because while it would be fine to just have these here and not do anything with them, that would mean they were pretty much useless, right? And we want to omit these events because they're going to be helpful to people outside of the blockchain to know what's happening. So first of all, what is this event? Contract initialized. Well, it's pretty straightforward. This event should get emitted when the contract is initialized. So if we go down to the init function, where we're setting all of our variables, we should just emit contract initialized, right? Boom, done. So there we go. All right. So the next one that we're going to need is the withdraw event. So where should we emit this event? Well, again, it's pretty straightforward. We want to emit this event when we withdraw an NFT. So, and it takes in an ID and a from, so who we're withdrawing from. So if we go down to our withdraw function, we can actually, inside of here, before we return the NFT, why don't we emit the withdraw event, The ID is nft.id because we have the NFT right here, so we're going to put the NFT's ID in the ID field, and then from should just be self.owner.address, and the little question mark here. So you may be wondering, well, what the heck is self.owner.address? Well, we went over this a bit in previous lessons, but basically a really, really important part of Cadence is that inside of a resource, if this resource is being stored inside of account storage, you have access to this thing called self.owner. Now, what self.owner is it's basically the person that currently is holding this in their account storage. So it's whatever account has this collection in the account storage. Now, what you can do is you can say self.owner.address, and that returns the address of the person that it's currently in. Now, the reason why I put this little question mark here is because remember before I did teach you that if we hover over this error, it says value of type public account question mark has no member address. Then the reason for that is because self.owner is actually it's a public account optional. So this is actually an optional type, what I'm highlighting right now. So in order to overload that, what we can do is we can put this little exclamation mark here, which means so unwrap the optional and just return an address here. But if we go up, and this is totally fine if you want to do this, by the way, because what this will do is self.owner will only ever return nil if for some reason this collection isn't in account storage. So this is like an edge case because 99.9% of the time it's going to be inside account storage. But if we go up here, you'll notice that from is actually an address optional type. So it allows you to return an optional here. So if we go back down to self.owner, what we can do to get rid of this error is put a little question mark here. And that will say, okay, if self.owner exists, then just return address. But if it doesn't exist, just return nil. So it's a really helpful operator for us to be able to return an optional here. All right. So the next part is the deposit function. So where do we want to do that? Well, we probably want to emit that when we're depositing an NFT. So inside of here, why don't we just say emit deposit. The ID is token.id, and the to parameter is self.owner.address. Right, so pretty straightforward again. Boom, we've implemented the deposit function. And so again, these are going to be really helpful for us because every single time an NFT is deposited or withdrawn, the outside blockchain will know those are happening. So services like Graphel, which I showed you last time, that are event indexers that search through events on the blockchain, a Graphel will be able to tell us that these two events happened and will relay that information to our front end or whatever application is reading from it. Cool. So those are all the events. Now, the next thing on here is a public resource interface called INFT. So like I said last time in contract interfaces, you don't have to replicate resource interfaces in your contract. So we wouldn't do this. We would not copy and paste it over. But what is important is that we use INFT however they use it here. So if we look at this sort of resource here, the next thing is a resource. We do have to copy this over, but we already have it. We already have an NFT resource. And you'll notice that their NFT resource implements INFT. So I went over this before, but the most common mistake I see is people will be like, oh, we need INFT. So they copy INFT over, right? And then they implement INFT on the resource. And they're like, oh, okay, I did a good job. I implemented the resource. And the answer is this is not true. You cannot do this. What you have to do instead is you don't bring over the resource interface like that. And what you do instead is you implement non-fungible token.inft. So non-fungible token refers to this contract, and then INFT is referring to this resource interface. And so again, because on this end it's referring to an INFT, you have to refer to this one right here because this is pointing to this. So this NFT also must point to this one specifically. So Kelcoin says contract name.resource interface. Yep, exactly. So contract name.resource interface. Boom, right there. Cool. So one other thing we have to check, does our NFT have a public let ID? Boom, it does right here. Now you'll notice, by the way, that as we work through this, the NFT contract that we built together actually already implements like 75% of this contract because I'm such an incredible teacher that I actually had us doing pretty much most of the work already. So taking a bow, you're welcome. The next part that we have to do is, there's a ton of resource interfaces here. So there's a provider, right? This is an entire resource interface. There's a receiver. There's a lot going on here. There's a collection public. There's a lot going on here. The good part is that we do not have to bring these over. Why? Because they are resource interfaces, so we don't have to replicate them in our contract. What we do have to make sure is that wherever these are used in this contract, we have to use in this contract, okay? So if we scroll down a bit more, the next thing that we need to have is a public resource collection. Do we have that? Public resource collection right here? We do, okay? But what we don't have is that their collection implements these three resource interfaces, and we do not have that. Now, one thing I want to mention is do not get confused between this collection public and the collection public defined here. They're totally different. Even though they look the exact same, I was only using this one for our purposes, but we're actually going to instead implement this resource interface right here. So what we can actually do, which is pretty cool, is we can sort of like, delete this for now. Actually, okay, we're not going to delete this, and I'll show you why in a second. But we're going to keep this here for now. But we have to make sure that our collection implements these three things, okay? So let's go ahead and do that together. So there's going to be a lot going on here. But we need to implement non-fungible token dot provider. We need to implement non-fungible token dot receiver. And we need to implement non-fungible token dot collection public. And for now, we can leave our collection public as well. So we can also just leave ours on the end, okay? So we just implement all the things on the collection, and now we're getting an error here. So resource babyjacob.collection does not conform to resource type requirement non-fungible token.collection. All right. So this is where things, in my opinion, get the most confusing. But I guess sort of like bear with me for a second. So before we move on, just to sort of like reiterate the point here. So when we implement the provider, the receiver, and the collection public, that means that this collection has to have all the things defined in these three resource interfaces. But if we scroll up here, you'll notice that the provider has a withdraw function, right? Do we have a withdraw function? We do. The receiver has a deposit function. Do we have that? Yep, we have that as well. And there's also a collection public with a deposit, a get IDs, and a borrow NFT. So here's a deposit, here's a get IDs, and here's a borrow NFT. So it may seem really easy, and it is, but it's only because we've actually implemented all these things previously, right? So we got sort of lucky, or also because I'm a fantastic teacher, that all of these things are already implemented in the contract for us. So implementing these resource interfaces was really easy for us because we already sort of had the requirements. Now, one thing I want to point out, and the reason that I taught you pre and post conditions the other day was because look at this, for example. Here's a post condition. So in this post, like what is this post condition actually doing? Well, it's saying that inside the withdraw function, it's saying the result.id, and remember, result is referring to the return type. So it's saying result.id, so the NFT's ID that we're returning has to equal the withdraw ID. That's a really cool check, right? Because it's basically saying, hey, is the NFT that's returned, is it the withdraw ID that we actually requested? So it's adding another level of security to our contracts to make sure that in the withdraw function, the person implementing it doesn't accidentally, withdraw an NFT that's completely different from the one they requested right here. So that's like that's sort of why I taught you post conditions, was just to understand this one line of code. But hopefully it's helpful in other aspects of the Cadence world for you as well. All right, so on to the probably the most confusing part of this contract. And look, we're actually almost done, by the way, so it's not even too bad at all. But yeah, the most confusing part is the fact that just like up here, so if you scroll back up for a bit, just like in this case where on our NFT, right, on this side it says INFT, but on this side we have to say non-fungible token.INFT because we're referring to this one right here. It's the exact same when it comes to the NFT type. So even though the NFT type is a resource, it's no different than what we were seeing before. So instead of putting NFT here, we have to put non-fungible token.NFT. And the reason for this is because, again, this NFT resource is referring to this NFT right here. Whereas when we actually implement the contract, this NFT resource here has to refer to the same one, which is this NFT right here. Okay, so it is a bit confusing, but that is sort of the general, gist, is that we have to make sure that our types on this side are implementing the type that this contract interface is specifying on the right-hand side. So if we scroll back down to our collection, now our owned NFTs is perfectly fine because it is a non-fungible token to NFT, which is the type that it wants. But you'll notice that if we sort of scroll through this collection, there's a bunch of other areas where we have to make sure we're implementing, that exact same thing here. So on the right-hand side, you'll notice that deposit is depositing an NFT resource. Sorry, I just had to cough. So you'll notice that deposit is depositing an NFT resource. So on the left-hand side here, once again, we have to change this to a non-fungible token .nft to make sure that we're referring to the correct NFT type. So we can do the same exact process for all of these. So the withdraw also must have a non-fungible token .nft, right? And borrow NFT must also be the same exact type. And we also have to replace the the cast here to a reference to an NFT. We replace that as well, and then boom, we are one step closer to total success and victory. So we're getting some other errors here. So we're saying resource babyjacob.collection does not conform to resource interface babyjacob.collection public. So it's actually really helpful that the cadence errors prefix each of these types with the name of the contract, because we know that babyjacob.collection is this right here, right? So it's this right here. And it's saying it does not conform to babyjacob.collection public, which is not referring to non-fungible token collection public. It's referring to this one right here. So I'm going to pause here. Does anyone have any idea why after we replaced all the NFT types with non-fungible token.nft, do you have any ideas why it would give us an error about this now? What is it about our collection that does not conform to this? I'll give you a hint. It's something to do with the types. Does anyone have any guesses? Exactly. It's two different types of resources calculating. That's really great. So the reason it's giving us a problem is because this resource interface says we must have a deposit function that deposits this NFT, which refers to this NFT right here. Whereas in our deposit function, we're depositing a non-fungible token NFT, which is referring to this one right here. Right? So we actually have to change these types as well to fit the standard. So if we go ahead and change these two, then boom, our collection no longer has any errors on it. Yay, that's awesome. So our collection is now done. And we're going to revisit this in a second because there's one more thing we're going to want to change here that's pretty important. So if we scroll down a little bit, there's one more thing we have to do. So after a collection, there is a public function create empty collection here. So what we can do is, this is referring to a collection, which is defined right here. So again, in our contract, we have to refer to the same type. So we have to say non-fungible token dot collection, and then boom, all the errors are now gone, and we have totally completed our NFT contract. So huge round of applause. Woohoo! Woo woo! Because we now have a totally functioning NFT contract that is super, super, super cool. Now, there's one more thing I want to note, and this is a very complex topic on Flow, probably one of the more complex topics. And it's actually funny that Bjartek is here because this is a problem that Bjartek has spent a lot of time on. But the next part of this section is saying, now that we've actually implemented the standard, there's some things that are now going to go wrong in our NFT contract. And one of those is the fact that if you look at this collection now, remember way back when we were talking about the fact that, inside of your collection, you want to be able to read information about your NFTs without, like pulling the NFT out of the without pulling the NFT out of the collection, reading information and then depositing it again, right? We want to be able to read information about the NFT just by borrowing a reference. And so the way that we fixed that is we added this borrow NFT function. And what this function did was previously it returned a reference to the NFT. So we could borrow the NFT, we could read a lot of metadata from it, right? And all would be good. Now, the problem now, does anyone see a problem with this current collection? Because let's say in our NFT, right, we have an ID and we have a name. But look at what we're returning right now. We're returning a non-fungible token to NFT. which is, if you look at that NFT, look at what it's missing, right? It only has an ID. So what's going to be the problem if we want to read the name about this NFT? What's the current issue? Are we talking about the same NFT that we create? So when we create an NFT, so when NFTs get created in this contract, they're going to get deposited into this collection still. Because these NFTs, so while I keep emphasizing the difference between this NFT and the NFT over here, it is important to understand that this NFT is also this NFT. It's just that this NFT is like the more abstract type. So every single NFT on Flow is this type. It is a non-fungible token NFT. It's just that this resource is a more specific version of it. So yeah, I'm curious, does anyone have any ideas for why this might be a problem if we want to read metadata about our NFT? What's the only thing we're going to be able to read from this type? So we need to specify the NFT we want. Yeah, so that's pretty close to the answer, Kelcoin. Although I'm curious to see if Bam or anyone else has like a more specific answer, but that's very close. Exactly. So Kelcoin read, I read something in chapter 5, day 3, a downcast. That's exactly what we want to do. You're totally correct. So inside of our, contract here, we need to do exactly what Kelcoin said. So boom, round a gold star for Kelcoin for saying downcast. That's exactly what we need to do. So downcasting is like sort of what we need to do. But we sort of want to talk about why that actually is. The reason for that, and Bam is still typing, so Bam, I'm curious to know if you have an answer for this, because I'm sure you do, because you're pretty experienced at this point. But the reason that we have to downcast is because when we return this reference to the caller, what's going to happen is this, when we return this to the caller, the caller is only going to have access to a non-fungible token to NFT type. Now, the problem with that is that if we look at this resource over here, right, this is the one that it's referring to, it only has an ID field. So we're going to run into a big problem when we want to read the name, because it's not going to allow us to read the name here. So in order to sort of fix that, what we have to do is quote unquote downcast this NFT to fit, to actually be able to read the field here called name, right? So what we're going to do is we're going to add another function here. And by the way, I'm going to lead us through this process, and then I'm going to explain the metadata standard, which is actually something that that helps solve this sort of problem. But we're going to get there in a bit, and I'm just going to go with this for now. So what we can do here in the borrow is I'm going to call it like borrow, I don't know, entire NFT. I don't know, I can't come up with a better name. And we're going to put an ID here that's a uint64, and we're going to return a reference to a non-fungible token. So not an NFT, not this type, but the NFT that's right here, right? So that way we can read the name about our NFT. So if we scroll back down, what we can do is say, let reference equals a reference to self.owned NFTs, the ID as, and then hold on, I'm gonna mess up here on purpose. So non-fungible token. Right. So what this is going to do is get a reference to self.owned NFTs at ID, right? So just like we're doing here, right? Just like how we get a reference to the NFT with that ID and we typecast it to a non-fungible token at NFT, we're doing the same thing here, where we're saying, okay, we're going to get a reference to one of the NFTs as a non-fungible token.nft, right? Super cool. Now, the issue is that we want to return this type, not this type. So how do we go from a reference to a non-fungible token NFT to a reference to NFT? How do we go from one to the other, right? So in order to do that, what we need to do is downcast, which is what Kelcoin was referring to, this type to this type. Now, when you think about it from a more like abstract point of view, we call it downcasting because this type is like a more higher level type than this one, right? Because every single NFT on the blockchain, on the Flow blockchain, is this type. They're all an abstract non-fungible token NFT type. But our NFT is a more specific version of this one. It's at a lower level than this one, right? Because this type is this type, but it does not go the other way around. So when we say downcast, we're saying we're going to take this type and make it more specific to be our NFT. So in order to do that, we have to use something called Auth References. Now, an auth reference, I never actually directly taught this, but this is really interesting in the context of NFTs, is you have to put this little auth keyword here. Now, what that's going to do is it's going to give us an authorized reference to this NFT so that on the next line, what we can do is return reference, and then we can downcast it by doing this little as exclamation mark here, and I'll explain this in a second, to a reference to an NFT just like that. So what this is going to do is say, okay, give me a reference to, and you know what we can do just to help you sort of understand? We can even specify the type of this to be an auth reference to a non-fungible token NFT, right? So this is the type of this variable here, equals a reference to self.owned NFTs at the ID as an authorized reference to non-fungible token NFT. And because it's an authorized reference, on the next line, we could say, okay, take the reference, do a downcast by doing as exclamation mark to a reference to an NFT. And so what this is actually doing is this is saying, okay, take the reference, and if we can downcast it to a reference to an NFT, do it. Otherwise, abort the program. So it's really helpful for us to be able to put this here, and now we'll downcast it. And now the cool part is anyone that wants to read information about our NFT, they can, they can take this type and they can read the name, all they want. So it's really helpful for us to be able to read the metadata about an NFT. Awesome. Now, before we go on to the metadata standard, and the metadata standard is sort of like an alternative / better solution to doing this. Does anyone have any comments about what's wrong right now with our collection? And I'll give you a hint. Is the public going to be able to call this? And if not, how do we fix that? Does anyone have any ideas for how we can for how we can make sure that the public can call this function? Come on, guys. I know you definitely know how to do this at this point. I believe. Cubic Gray, I bet you know how to do this. Smart Cookie. Willy Blue, I bet you know. SWT, you probably know. Public path, exactly. So we need to be able to expose this to the public path. So in order to do that, what can we modify, about our resource interfaces to make sure that people can call this? Did we forget to add it somewhere? And hint, I'm talking about this right here. Yep. So Bam got it. So it's a resource interface here. So I know most of you know how to do this. I bet most of you are probably either just tired, but so this is actually what we were talking about before, which is a resource interface. So we have to make sure that we add our function to the resource interface above, which allows the public to now read our collection. Because remember, when we link this collection to the public, we link it, we restrict it to this type. So if we didn't add this function to the resource interface, then the public wouldn't be able to read this this function. So we have to remember to add it here. All right. So now theoretically, anyone would be able to, inside of their script, they would be able to get a public reference to this resource interface and call this function. Woohoo! So that is, if you've gotten this far, that is, a pretty good way to read NFT metadata, and it's a pretty simple solution, I guess. Yeah. And so for the record, the reason that remember before when I was saying well, we can just delete the collection public if we want. The reason that I didn't end up doing that was because the collection public on this side, you'll notice, doesn't have the borrow entire NFT function. So we have to have a totally separate resource interface over here called borrow entire NFT. So that we can allow the public to call this, and then that's why we still implement it right here on the collection. So before we go on to a pretty cool topic, but also a pretty complicated topic, does anyone have any questions about this so far? And for the record, what we've done so far, you can pause here, and this is a completed NFT contract. So if you were to deploy this contract on mainnet, this would be a totally fine contract. It allows you to have an NFT with a name. You could add any other fields here, and this works totally fine. So that's that. It's pretty exciting. But yeah, any questions so far? All right. Awesome. Awesomeness. Oh, a minted event. Very interesting. So yeah, that's a great idea by Bjartek. So what we can do is, it's not necessary, it's not necessary for the interface, but it's a fantastic idea to add another event here called minted. Now usually what minted is for is it allows you to sort of we could use it for whatever we want, right? But what we can do is we can have a minted event for when a NFT is actually created. So if we want to, we can add an ID here, and we can also, let's just add a name, right? Because let's just say we want to read the name of the NFT that was minted. So inside of our NFTs init function, right, when it gets minted, we can go down here and say emit minted. The ID is, the ID is self.id, and the name is self.name, right? So now anyone on the blockchain, like Graphel, can query through our events and know that an NFT was minted with this ID, right, and this name. So boom, there we go. There's our minted event. And yeah, Bjartek is totally right. It's really good practice to be able to mint events on any state change, because it's really important to know when things are happening. And to give you a real world example, let me actually show you. Let me go ahead and show you the float contract, because I think it's really important to becoming a better Cadence developer, to always be looking at other contracts and stuff. I mean, that's pretty much how I learned, which is reviewing other people's contracts. So if we actually go to the float contract, you can see that we have a ton of events here, right? Contract initialized, a minted event, a float claimed event, a destroyed event, right? When a float's transferred, when a float event's created, when a float event is created by a shared minter, right? There's a lot going on here. Float event destroyed, right? So there's a lot going on. But if we actually scroll through, we can see that, let's actually go to where, right here. So there's a lot of complicated code, but you can see that in the init function of the float contract, you can see that we emit a float minted event with the ID, the host, the event ID, the event image, the recipient, the serial, right? So boom, there's a real life example of a minting event, which is pretty cool. And if we keep scrolling, we can find a bunch of other events if we wanted to. I'm thinking, where's another one we could find? Oh, here we go. So this is a really good example, actually. I'm glad Bjartek sort of brought this up, but inside the claim function of an event, so this, you probably can't even read this. Let me increase the font. So this is a claim function that's inside of an event. So this function gets run every single time someone claims something. So in this, there's a lot going on, but if we scroll down, you'll see there's an event called float claimed, and this is an ID. It's an event host. It's an event ID. We pass in the event image, the event name, the recipient, the serial. But most important for me, the reason I added this was because I want to know the event image. Now, the reason that I want to know the event image is because if you go to floats.city/live, this is all on testnet, but this page, this is live claiming feed powered by Graphel. Every time that someone claims on the blockchain, it's going to emit this event. Graphel is going to query through all these events, and then it's going to display that to my front end here and start shooting things up the screen. And you know what? Because I think this will be really cool, like as a learning experience, why don't I go ahead and just like create a new event here? I'm going to call this final, like Emerald Academy workshop. The event URL, I'll just put in like a random one, right? The event description is this is the final workshop for Emerald Academy. So sad. And then we'll add like an event image here. So let's just add Emerald City. And now if I scroll down and create this float, what I'm going to have all of you do is you're all going to claim this float, and then we'll see the images fly up through the screen, which is super, super awesome. And that's like sort of a real life example of why events are so powerful. So let's wait for this to go through. And, as a disclaimer, this is still all in testnet, so it's nothing exciting, but, you get the point. So if we take this, I'm going to put it in the chat. So all of you go to this page and start claiming. I'm going to claim myself, too. And what we can do is I'm going to go to the live page, and so that you can all see Graphel querying events in real time. So let's wait for this to claim, and then I'm going to go there. All right. So everyone, make sure to look at my screen, because this is it's gonna be super cool. At least I think if Graphel is working, well, hopefully it is working. I think it should be. So look, here it is. Boom! Look at it flying through the screen. Right. So there it is, right there. Awesome, right? That was a Graphel reading the event happened, and when you guys claim more, it should show more images flying through the screen. So let's see if anyone else claims. Oh, look, here's 2 more flying through the screen, right? Super cool. So this is, again, oh, and actually, so the reason I open up the console is because let's go ahead and look at what's being logged in the console, right? Look inside the the block event data. There's an event host, there's an ID, there's an image, a name, a recipient, and serial, right, in here. And if we go back to our code, it's the same exact thing. An ID, a host, an ID, image, name, recipient, serial. Those are the same things that are being logged right here. So it's a perfect example of, why events are so cool, right? So I'm glad that we went over that topic.
So, Jacob, this is Bjartek.
Hey, Bjartek.
So just to chime in here. So the really important thing here in my eyes that you've done here, and it's a really good example, is that you add human readable data to the event. Because as you emit the event and as it is sent to the front end, you don't have to do another query to your backend to display what's going on. You have all the data you need to just display it to the user.
Yep.
And it's a really important technique to use to be able to scale applications. I guess it's more of an advanced topic, but it's still nice to lead into that topic, right?
Yeah, it's such a great point. Yeah, the reason, like Bjartek is saying, the reason why this is so powerful is because imagine what we would have to do if we didn't use events, right? Imagine what we would have to do. We would have to constantly on our front end, constantly query the back end and say, were there any state changes? And if there were, we'd have to parse through them so that we didn't get the old ones, right? We would have to read the new data, relay that back to our front end, which is extremely inefficient and really painful. But instead, we can use events to almost tell us when something's happening so that we don't have to know when it's happening ourselves. And that's why you can see that all of these sort of like logs here, these are all coming from Graphel. I did none of the work here. Graphel is automatically reading the events. And look, people are still claiming. Graphel is automatically claiming the events and telling my front end that something's happening. So just like Bjartek said, it's so much more efficient to do it this way. Yeah. All right. Awesome. So if we go back to the our contract here, the last thing I want to talk about is the metadata standard. So I'm going to go ahead and pause sort of like this, like what we've been doing, because we've been doing, we sort of finished with our contract. And the metadata standard is a more like complex topic that what I really want to do is I want to do a whole separate bootcamp on the metadata standard. This bootcamp was like a 4-week long process. I want to do a 1-week long bootcamp that's only on the metadata standard to help get people developing on it. So I'm not going to go too in depth on it because, again, I want to make it a separate bootcamp. But to introduce you to what the metadata standard does is it allows us to read. Actually, I guess Bjartek, since you're here, if you want to give an explanation for your own thing, you can go ahead.
Yeah, sure. So yeah, as Jacob said, it's my thing. Well, we were some guys that saw this problem. So the problem here is, how do you discover things and read things about NFTs without knowing about it before? That's kind of the problem, because the borrow method here that Jacob made, so that method, the name of that method is different for any NFT. And the name of the interface, the contract interface you have, is also different for any NFT. That means that you have to know everything in order to discover things. And that's not a place you want to be. You want to be able to discover and browse and find out things. So what we did with the metadata standard is to standardize an interface that is now deployed to mainnet. It's in a contract called metadata views in the same address as the non-fungible tokens. I'm not sure if you have it there, Jacob, and can show it to them.
Yeah, let me pull it up. Actually, I'd like to go to the view source.
Yeah, just do it while I talk. So there you have it. You can just click it. Okay. Yeah, so here it is. So you have a public resource interface for a solver. There's 2 methods, get views and resolve view. So get views basically says, this is a list of all the types that I support. So this is all the ways you can view me, to view you as something. And then a method to take one of those views and resolve that. And note that return type is any struct optional. And that optional makes it a little bit harder to query out the data, but it's there for safety, because you don't want to panic if you can't support anything, because you want to discover, right? So if you ask for something that's not there, you should not panic. You should just say, sorry, this is not here. And more importantly, or even as important, is the next resource interface. So the resolver collection, that's something that you add to any of the NFT collections that enables you to then signal to everybody that my collection follows the standard. So you link that interface when you link, right, the metadata views resolver collection, and then you will have a metadata enabled NFT. Now, so this is the way we have to do it now. But in the future, when a PR and Cadence is merged that we're waiting on, this will be defaultly implemented for any NFT. So in the future, it will be easier. But for us that are still here early, we have to do a little bit of extra work.
Yeah.
But it's still, so in and it helps us immensely when we're going to add new type has implemented the add it. If it hasn't, then it takes
think we're losing you, Bartek. I don't know if it's just me, but I think we might be losing you.
Hey, are you there?
Okay, yes, I can hear you now. Nice. Well, I think it might still be bad. Yeah, I think what Bartek was saying that like, you know, right now, like this resource interface called Resolver Collection. So what you have to do right now is you have to implement this resource interface on every single collection. But in the future, what's going to actually happen is this will be like defaultly implemented on every single collection, so that we don't have to go through the extra work of doing all this. Oh, that's totally fine, Bartek. Thanks so much for tuning in. We'll see you in the next one. Bye, Bartek. So yeah, what he was saying, and again, like a lot of this is very complicated right now. Like, I'm not gonna lie, I don't think a lot of you like will be able to understand this just yet. But the main point of this is just to understand that right now, like if you sort of put on your thinking hat here and you think about like from a more abstract point of view, like, you know, how do we read metadata about an NFT? Well, the solution that I showed you was to add this borrow entire NFT function. But the issue with this is that like a marketplace or someone that's dealing with all different NFTs, they all have functions that are named differently and all return their specific NFT. So what that means is that in a script, you have to import every single contract that you're reading NFT metadata from. And I wish I could show you. Wait, let me look up Alchemy. Alchemy Flow NFT API. Please come up. I wish I could show you. GitHub script. Shoot. Alchemy docs, Alchemy Flow contracts. Maybe in here, mainnet. Get NFTs. Oh my god, I found it. Look at this. So everybody, feast your eyes upon the worst cadence code I think I've ever seen in my life. So, does everybody see the problem with this borrow NFT function? Look at what problem this causes. This is the Alchemy API script. Oh my god, right? It's terrible. So the reason that they have to, and look, do you see how long this file is? Look at this. Oh my god, right? It's painful to look at. So the problem here, you know, without going too much into depth on the metadata views, basically the metadata views contract is BRTech's way of solving this problem. Where Alchemy, so Alchemy is a service that like reads NFT metadata. What they do right now is they import every single contract that they support, all of them, right? And so the issue with this is that in their script, they literally check what case, like what type of NFT you're looking for, and they do a check individually on every single one of these. Look, if it's a get CNN NFT, if it's a get Chain Monster NFT, it's a get Gaia NFT, right? Get Beam. So this is probably the worst cadence code I've ever seen in my life. And, you know, like, unfortunately, it's because of the fact that every single NFT is read differently. So in short, again, we'll have a separate bootcamp on this, but in short, the reason the metadata standard is so helpful is because instead of having to import every single one of these NFTs, all you have to do is import non-fungible token and metadata views. And you'll be able to read metadata about each of these NFTs without importing all of them. So that is a very brief introduction to the metadata standard. And if all of you are more interested in actually implementing it, check out the video that Bam just sent, because that is a video that basically describes like how to implement the metadata standard. And that's with me and BRTech, just us two explaining the whole thing. So it's a great video, great resource. So definitely check it out. All right, everybody. So that sort of concludes this bootcamp. Just as a summary, this was an introduction to cadence. In this bootcamp, you learned how to basically go from no programming knowledge to deploying to writing your own NFT contract on the blockchain. And so I really hope you enjoyed this. I hope it was a helpful resource. And before I sort of let you go and give my concluding remarks, I want to quickly go over the completion list. So I know, so Bam, you had sent me earlier that someone had completed. Who was it? Oh, Skyon. Okay, so this is actually a spreadsheet I have of everyone that finished. So if you're not on this list right now and you did finish, please let me know. These are all the people that I've recorded that have finished so far. Has anyone else finished that's not on this list? Because these, by the way, these are all the people that are going to get the first float on mainnet. So everyone here is going to get the first float ever on mainnet. But I want to make sure I'm not missing anybody. And also, just for the record, so if you haven't finished yet, that is totally fine. I'm gonna give everyone like a few more weeks to finish. So if you finish like next week, that's totally fine. You'll still get the first float. So don't worry about it. We're not like the deadline's not today, so you have some more time to work on it. So don't be stressed. But yeah, like we won't have any more workshops. And I have a pretty big announcement to make as well, in a few seconds here. Thanks so much, Hero. Okay, so yeah, so if no one else is missing, that's totally fine. So we won't go over that now. But so one more thing I want to mention. So let me actually, while I talk about this, let me pull up academy.ecdao.org. So I just want to make a brief announcement. So this is fantastic news from your friends at Emerald City, but we believe that the Flow team will actually be funding our boot camps. So all of you just participated in the first boot camp ever in Emerald Academy. Well, the plan is to run this exact same boot camp over and over and over again every single month, because it's 4 weeks long. And every single month, we're going to teach the same exact boot camp that you all just learned to help onboard more people into the Flow ecosystem. So the boot camps, we're thinking that they will be funded by the Flow team. We're gonna get some Emerald City swag, so some Emerald City merch like hoodies and hats and all that kind of stuff. And so a lot of those will also go out to all of you for completing this course. So you can look forward to, hopefully look forward to some swag in the future. It's not going to be now, but will be hopefully in the future. And if you want to, even though you already completed this bootcamp, I really encourage you to come back. And this is also a big announcement from me, is that because that the Flow team is funding our courses, what we're actually looking for is we're looking for like teachers or instructors to help out in future boot camps. And so what that's going to look like is we don't really have like all the logistics worked out yet. And again, all of this could not be true, but this is like what we're thinking, is that people that complete the boot camp, which is all of you, would have the opportunity to come back for the next boot camp and teach people about what, the help review quests, help answer questions in the Academy chat. And if you do that, you'll sort of get your foot in the door to like help you explore the Flow ecosystem and have like your first like quote unquote job on Flow. And we will be paying people, we will be paying instructors to help do that. So if you have interest, and you completed this course, I personally believe that all of you would be able to help out in the next bootcamp because I think all of you are very smart and very capable. So if you're looking to sort of get your foot in the door and to have your first opportunity in the Flow ecosystem, reach out to me and I'd be happy to bring you on as an instructor in the next bootcamp. Like I said, it's the same exact bootcamp. So if you already completed all the quests and you understand everything, you would be able to teach in the next bootcamp because it's nothing new. So yeah, like I said, if you're interested in teaching the next bootcamp with me, and all that means is just reviewing quests and helping answer questions, let me know and we can probably get you paid and give you a good amount of cash just to help review quests. And also you get to spend time with me, which is invaluable, right? So that's that. And with that being in mind, that's all I have, guys. That's all I have. So yeah, reach out to me if you want to help teach. If not, I would really appreciate it if you tweeted on Twitter or reach out to your friends and family saying that you love this bootcamp. The goal here for Emerald City, this is not, it's not like a job for me. I genuinely enjoy teaching all of you, and I view all of you as my, my flow friends. I love getting to meet all of you. That's the greatest joy to me. So please, don't be a stranger in the flow space. If you're ever looking for, a helpful hand, or you're working on a project, reach out to me individually or reach out to Emerald City. We're here for you. This is it's a community. It's not, like a working environment. Even though we are a working, team, we're here for you. We're here to help you in your flow journey. And these boot camps are not just for, intro to Cadence. They're joining a pretty substantive community, to help you, grow. So definitely reach out. Don't be a stranger. I hope that you stay within the Emerald City ecosystem. And potentially one day I could see all of you helping to build, the future of DAO tooling. Some really cool Cadence smart contracts in here. And Emerald City is always open for contributions. We have tons and tons of products always coming out, and we're always looking for help. So if you want to get involved, again, you want to get paid, let me know. We have tons of stuff to go over. So that's the end of the bootcamp. Please, if you can, tweet on Twitter to get people interested in our bootcamps. And we're going to have another bootcamp very soon that I will announce to the Academy in a bit. So thanks, everybody. I'm waving at my screen. Love all of you. And hopefully I'll see you in the next bootcamp. And hopefully you will be instructing that bootcamp. So bye, everybody. Woohoo! We did it. Yay. Woohoo. Bye. First bootcamp done. We did it. Woo! Thank you, Hero. Thank you. Bye, Willy Blue. Thanks, Bam and Kelcoin, for helping instruct. Oh yeah, thank your instructors, Bam and Kelcoin. Thank you. And Bam as well for reviewing so many quests. Wow, thank you, Bam. So many thanks to Bam for helping to review all the quests. Thank you so much.